All right, so now we're going to be dealing with polynomial equations that have imaginary solutions. Okay, so this is not something we can factor. So as we know, we switch to the quadratic formula: b squared minus 4 times the a value times the c value. So my discriminant ends up being what? 36 minus 40 plus 12 is 52. Definitely going to be a negative number. So let's see, what would that be? 52 take away 30 would be 22, take away 6 more would be 16, so negative 16. Okay, so it's negative 16. We know that's going to produce imaginary numbers. So continuing on, we have opposite of b over 2 times a plus or minus the square root of, well, it's the square root of negative 16. Here, I don't know why I put an equal sign. We know that that's going to go under the radical. But what is, then I guess maybe I should just put it under there because I don't have to break apart the radical. So we'll get rid of this. And that's over 2 times the a value. So what is that? That's x equals 3 plus or minus. The top has 4i, and the bottom has 2, so that makes 2i. So we have 3 plus 2i and 3 minus 2i. Oh, looks! Complex conjugates. So just like the imaginary or the irrational conjugates, can't even spell. Just like the irrational conjugates, we have complex conjugates. Okay? Obviously, complex means they've got both a real component and an imaginary component, which means they do not show up on the x-axis. So, complex comments. Numbers of the form a plus or minus bi. Okay? So what is the imaginary root theorem? If a plus bi is a solution, then you automatically know that a minus bi is a solution. Also, if a minus bi is a solution, or a root, or 0, why are they calling it a 0? Well, it's a 0 in the sense that it causes the equation to be 0, but it's not an x-intercept, so don't get that confused, because it doesn't show up on the x-axis. But if you know a minus bi, you also know a plus bi. Okay, so that's the whole idea. These things come in pairs, just like the irrational ones that we looked at. All right, so if I give you solutions, you have to tell me if there are any, and I do mean if there are any additional solutions. Remember, we're only changing the imaginary sign. So 2 plus 9i would have its counterpart 2 minus 9i. Negative 7i would have its counterpart positive 7i. On b, we'd have negative 6 plus 5i. For 4i, it would have negative 4i. 15, negative 15, does not have an imaginary value, therefore it doesn't have any counterpart that goes with it. 7 minus 3i would have its counterpart, 7 plus 3i. So remember, don't just start slapping negatives and changing signs on things that don't get it. You must understand whether it's an irrational solution or an imaginary solution in order to use those theorems. Don't just, do whatever you feel like doing. Please. Example 2. Write the polynomial function in standard form with the given root negative 9i. That means that positive 9i also would work. So we're going to have x minus 9i and x plus 9i. Remember which one goes with which, right? This one goes with this one goes with that. And of course we have y equals. And yes, we are going to use the box, unless you hate boxes. In that case, don't use the box. Draw your little arrows, firsts, outsides, insides, last, just like you learned in Algebra 1 stuff. Firsts, outsides, 9xi, Inside's negative 9xi. And lasts, this one down here is negative 81i squared. Oh, by the way, what is I squared again? Isn't that just negative 1? So you're saying negative 81 times negative 1? Well, isn't that just positive 81? Yeah, it is. And wait a minute, Mr. Stailey, don't those two boxes cancel out? Yes, they do. So you're saying the final answer is y equals x squared plus 81? Yes, I am. I sure am. Remember those boxes, when you do the conjugates, those boxes are going to cancel out. It works like clockwork, and it's kind of nice to see that happen. Okay, so write the polynomial function in standard form with negative 5. Ah, no I there, so there's no counterpart. We do have 3i, so that means negative 3i is also a solution. So we're going to have three factors here. Y equals x plus 5, right? X minus 3i, and x plus 3i. I'm going to do the imaginary ones first. X minus 3i, x squared. This box and this box are going to cancel out, so why waste my time? Negative 9i squared, which is really negative 9 times negative 1. Positive 9. So now I have x squared plus 9 times x plus 5. Keep the boxes rolling, right? X cubed, 9x, 5x squared, 45. Final answer, y equals x cubed plus 5x squared plus 9x plus 45. Write the polynomial function in standard form with this, so that would also have a counterpart of 2 minus 5i. Okay, so now I've got my x minus 2 plus 5i. Oops, forgot my y equals. And my x minus 2 minus 5i. Of course, I'm going to recommend, as I have before, distributing the negative 1. So that'd be x minus 2 minus 5i. And distribute the negative, getting x minus 2 plus 5i. And now I'm going to do my bigger box, right? My 3 by 3 box. Now, if you remember what happened the last time I did this with the irrationals, then you're going to remember this box and this box will cancel. This box and this box will cancel. There's literally only 5 boxes to worry about. We got x squared minus 2x minus 2x plus 4. And then down in this corner, we have minus 5i squared, which is equal to minus 5 times negative 1, or, oh no, that's not right, minus 25i squared. So that's really minus 25 times negative 1, or positive 25. So then I can rewrite this. Y equals x squared minus 4x plus 29. It's always important to catch your own mistakes if you can, because that's a critical thing in life. You do not want to, let your own mistakes go past. If not, you always want somebody to find them for you and help you out, including me. I like that help too. Okay, 7 minus 4i, and then we would also have 7 plus 4i. Okay, so y equals x minus, parentheses, 7 minus 4i, x minus, parentheses, 7 plus 4i. Distribute the negative, x minus 7 plus 4i. Distribute the negative, x minus 7 minus 4i. Then write the other one down the side, x minus 7 plus 4i. Remind yourself which ones cancel out, those two, okay? So x squared minus 7x minus 7x positive 49. And down here I have negative 16i squared, which that's really negative 16 times negative 1, which is positive 16. So final answer, y equals x squared minus 14x plus 49 plus 10 would be 59, and then 6 more would be 65. So, just a lot of practice with FOIL. Okay, that's it for that set of notes.